students, welcome to Go Vidya and welcome back to the 1000 important series questions, and today we will be discussing about the induction machine questions. So let's move to the first question. Three phase voltages are applied to the three windings of an electrical machine. If any two supply terminals are interchanged, then the rotating MMF are. So in any machine, in induction machine, we have to create the RMF. In order to create the RMF, we have to give the three-phase balanced supply, and this then will create an RMF. And if you are using a distributed winding, we will create an rotating magnetic field. And in this rotating magnetic field, to create this rotating magnetic field, we have to give a phase sequence. It depends upon the phase sequence. If in the phase sequence, so suppose I am giving A, B, C phase sequence. If I change any of the or interchange of the two phase terminals, then the phase sequence will be reversed. As the phase sequence is reversed, definitely the direction also will be reversed. The direction will also be reversed. So in the question, in the options, if you see, they have asked about the direction and the amplitude. Definitely if you are interchanging the two supply terminals, we are getting the direction to be reversed. Next, the amplitude remains same because it depends upon the supply and its characteristics also remains the same. So the option, the answer will be direction will be reversed. And the second one is amplitude remains same. Unaltered means remains same. Altered means same. So direction reverses. In the option A, direction reverses. Option B also we can find the direction reverses. In the option C and D we can find direction remains same. So this is wrong. So option C and option D are wrong. So the answer will be in between A and B. The amplitude alters. Amplitude alters means changes. No, the amplitude will remain same. So the answer, option B, amplitude unaltered. So the answer will be option B. Clear? So let's move to the next question. The rotor of a three-phase 5 kilowatt 400 volts 50 hertz slip ring induction motor is wound for 6 poles, while its stator is wound for 4 poles. The approximate average no-load steady state speed when the motor is connected to 400 volts 50 Hz. So, if you see the question, the rotor is wound for the 6 poles and the stator is wound for 4 poles. Actually, we have some of the conditions. In that, one condition is that we should have the number of poles that in the stator and the rotor should be same, should be equal. But coming to in this question, we have the different number of poles. As we are having the different number of poles, there will be no motoring action. Because of no motoring action, the speed will be 0 RPM. So the answer for this question will be 0 RPM because of we have two unequal, means the poles are not equal both in the stator and the rotor. Clear? So let's move to the next question. The stator of a three-phase 50 Hz 1440 RPM squirrel cage induction motor is replaced by a stator of 6-pole motor. Without any alternations, the motor will. So the question the question is about the squirrel cage induction motor, and the stator is replaced by 6-pole without any alteration. So we have to find the motor. The motor will run at. So we will find that. So Ns is equal to 120 F by P, 120 into 50 by number of poles are 6. So we will get 1000 RPM. But in case of squirrel cage induction mode, what happens? It automatically adjusts with the number of stator and the rotor poles. It automatically adjusts. So with that special criteria and the squirrel cage induction motor, the speed, the motor will run here at less than 1000 rpm, not equal to 1000 rpm, because nr and ns will never will be equal. It will be nearly equal. It will not be equal, it will be nearly equal. So the answer will be, it runs at less than 1000 rpm. Clear? So let's move the next question. The starting torque of a three-phase induction motor varies as. So we have to find the starting torque, and it will vary as nothing but it will be directly proportional to which parameter. So we'll find that. I'm writing direct the formula. In the last class we have discussed some of the basics regarding the definitions and the formulas also. So TST is equal to K into E2 square by X2 square into R2. So this is the starting torque. Now here K is equal to 180 by 2 pi ns. 180 by 2 pi ns. We know the formula ns is equal to 120 f by p, which is ns is directly proportional to frequency. If ns is directly proportional to frequency, then what is the relation between the k and ns? Inversely proportional. So I can write ns is directly proportional to 1 by f. And moreover, we have the x2 in the denominator, x2 square. So I can write x2 is equal to 2 pi fl. If x2 square, definitely frequency also will be square. I can write x2 square is directly proportional to frequency square. So I can substitute this value here. So 1 by f square. So ns directly proportional to 1 by f cube. So in the question they have asked the starting torque of a three-phase induction motor varies as. It will be directly proportional to 1 by f cube. So the option C. And a small question to you. We have found here the starting torque. Just give an answer in the comment box regarding the maximum torque. In the same way, maximum torque of a three-phase induction motor varies as. So for this question, the following options A, B, C, D, and give your answer in the comment box. And one more thing I have to say to you, in the last class, a small note I have to say. In the last class, the last problem, actually I have set the answer 1.2 because of some calculation mistake. Actually the answer is 0.12. Please check over it. Please check it the answer and modify it. The answer is 0.12. Okay. Coming to this, you find the answer for this question and give answer in the comment box. Clear? So let's move to the next question. If you observe this question, last question, it looks very simple. But if you know the basic formulas, definitions, and if you know everything only, you can do like these problems. Clear? So let's move to the next question. When the input voltage and the frequency of a three-phase induction motor is halved, the following phenomena is observed approximately. In the question they have given the voltage and the frequency is halved. So we have to find what is the maximum torque. So for finding the maximum torque, we have to know the relation T max is directly proportional to V by F whole square. If the voltage is half and frequency is also half, definitely the T max will be constant. If one of the parameter is half and other is doesn't change, then T max will obviously change, it will vary. But both the parameters, the voltage and the frequency, are varying with half, changing with half, and this is also half. So definitely the T max will be constant. So option A, the maximum torque is halved. No. The maximum torque remains the same. Yes. That air gap flux is halved. No. The answer is the maximum torque remains the same. So clear? So let's move to the next question. The presence of dominant seventh harmonic in the winding distribution of a three-phase 6-pole 50 Hz induction motor may cause the motor to crawl at a speed of. So we have to find the crawling speed. We have to find the crawling speed. So understanding the question is very important here. Understanding the question. So we have to find the crawling speed. Crawling speed. So the given data is, it's a dominant 7th harmonic and it has 6 pole 50 Hz. So to find the crawling speed, we have to know the formula. The crawling speed for the 7th harmonic is ns by 7. So for calculating the crawling speed, we have to calculate the ns. ns is 120 f by p. 120 into frequency they have given as 50 Hz and the number of poles are 6 poles. So 6 20s and 20 into 50 is 1000 RPM. But don't stop here. The question they asked about the crawling speed at 7th harmonic. That is ns by 7. Crawling speed. So the ns we got is 1000 RPM. 1000 by 7. You will get around 7 ones. 3, 0, 4, 28, 2 zeros and 3. Around you will get 143 RPM. Clear? So the answer will be 750 no, 500, 242, 143 RPM. If they have given in the question 11th harmonic, just you find the synchronous speed and you divide by the 11th harmonic. You will get the crawling at a speed, crawling speed. Clear? So let's move to the next question. A center zero ammeter connected in the rotor circuit of a 6-pole 50 Hz slip ring induction motor makes 45 complete oscillations in 1 minute. In RPM, the rotor speed and the speed of stator field with respect to the rotor are. So in the question they asked the rotor speed and the speed of stator field with respect to the rotor. So we will find that. So it's saying that 45 oscillations in the 1 minute. So F2 is equal to F2. They didn't mention about the slip. So we have to find the slip also. F2 is equal to 45 by 60. 1 minute means 60. So 15 threes and 15 fours. 3 by 4 is 0.75. So F2 value. And we know the formula when it is referred to the rotor side. F2 is equal to, when it is in running condition, we know the formula F2 is equal to S into F1 or F. So S is equal to F2 by F1. So the F2 value is 0.75 by, and F1 is 50 Hz. You will get 0.015, the slip. The slip we got. Now we have to find the rotor speed. The formula is NR equal to 1 minus S into NS. But in the question NS is not given. We have to find the NS value. NS is equal to 120. F is 50. By poles are 6 poles. You will get 1000 RPM NS. So after getting the synchronous speed, after finding the slip, we will find out the NR. NR is equal to NS is 1000 1 minus, what's the slip value? 0.015. You will get around 985 RPM. So the rotor speed we got, so the first we got is 985 RPM. Now the second question is that speed of stator field with respect to the rotor, that which is NS minus NR. So 1000 minus 985, which is 15 RPM. So this is speed of stator field with respect to rotor. So the rotor speed is 985 RPM. So A, B, C option 985 RPM is available. So 15, 985, 1000, 970. So the question they asked, the speed of stator field with respect to the rotor is NS minus NR. NS we got is 1000 RPM and NR we got is 985 RPM. So the speed of stator field with respect to rotor is 15 RPM. So the option A matches with the question. Clear? So let's move to the next question. A 3-phase 4-pole 50H induction motor at a speed of 1440 rpm. So the first question is its slip is 0.05. So we'll calculate that. So in the question they have given the NR. NR is 1440 rpm. So NS is not given. We'll find that NS is equal to 120, F is 50 and P is 4 poles. For 30 is 120, 30 into 50 is 1500 rpm. So slip we have to find. S is equal to, the formula we know is NS minus NR by NS. So NS is 1500 rpm minus NR is 1440 rpm by 1500 rpm. So 60 by 1500. Twos 50s, 3 twos 350s, 1 by 25. 1 by 25 is 0.04. 1 by 25. So S is equal to 0.04. So the slip is 0.05. It's correct. Option 1 is correct. So its rotor field rotates at 60 rpm with respect to rotor. So what we do is, we'll make some epic diagram of that. So this is the stator and I'm giving a 3-phase balanced supply, 3-phase balanced supply to the distributed winding. Then I will get an RMF. So the sequence I am giving here is ABC sequence here. Now as I am giving the 3-phase balanced supply, now the machine may start rotating. So it will rotate with the speed of NS. So this will be stator field. So we have already found the value of NS, that is 1500 rpm. Now due to some torques, the rotor will also start rotating here. If this is rotor, this is the rotor field. So this will be NS minus NR and this will be NR. Because the rotor starts rotating with NR speed, then after it will rotate, the relative speed between the rotor and the rotor field is NS minus NR. So we will find some of the conclusions from this. The rotor field rotates with respect to rotor. What is the relative speed between the rotor field and the rotor? NS minus NR. Second question, this is NS minus NR. Rotor field with respect to rotor is NS minus NR. So NS is 1500 minus 1440 rpm, you will get around 60 rpm. So they have given 60 rpm, which is correct. So let's move to the third question. Its rotor field rotates at 60 rpm with respect to the stator field. So what is the relative speed between the stator field and the rotor field? It is lying on the same line. Yes or not? As it is on the same line, what is the relative speed between the stator field and the rotor field? It will be 0. It will be 0 rpm. Clear? So the option 3 is wrong, because we will get here as a 0 rpm. Next, fourth one. Its rotor runs at a speed of 60 rpm with respect to stator field. Stator field and the rotor. What is the relative speed between the stator field and the rotor field? So that will be NS minus NR. Already we know the NS 1500 and NR is 1440. The difference of this is 60 rpm. So the fourth option is correct. So the fourth option will be NS minus NR. This is the relative speed between the stator field and the rotor. And the fifth question, the rotor field rotates at a speed of 1500 rpm with respect to the stator. So they are asking about the rotor field and the stator. This rotor field and this the stator. So if you observe here, this is NR and this is NS minus NR. Just add it, you will get only NS in simple. But to answer like these questions in the exams, you have to know this diagram, whether it is connected to the rotor end or the stator end. Clear? So for the fifth, the option will be 1500 rpm, because NS minus NR plus NR, which is NS. NS we have found that 1500 rpm. So 1 is correct, 2 is also correct, 3 is wrong, 4 correct, 5 correct. 1, 2, 4, 5. So the option A matches. Clear? So let's move to the next question. If the full load speed of a 3-phase 50H induction motor is 950 rpm, what is the half load speed nearly equal to? So NS is equal to 120 F by P. So 120 into 50 by, we will take as 6 poles. We will assume as a 6 poles, because which is nearly equal to 950 rpm. So we will take as, take P is equal to 6. You will get 6 to 1000 rpm. So now calculate the slip. S is equal to NS minus NR by NS. We can take an assumption, no problem in that. So NS is 1000 rpm minus NR is 950 rpm by NS. Because in induction machine, never NR will be equal to NS, it will nearly equal to NS. So that's why I have taken the pole P is equal to 6. So 1050 by 1000 you will get. So 5 by 100, 0.05. But in the question they have asked about the half load speed. So the slip S2 is equal to S1 by 2. So 0.05 by 2. So the 0.05 you will get 0.025. So we have to calculate the half load speed. So NR is equal to 1 minus S into NS. So 1 minus S is 0.025 into NS is 1000 rpm. So 0.075 will get around 975 rpm. NR is equal to 975 rpm. So it's said to be calculated in the half load speed. So 975 rpm. Clear? In the half load speed, if you observe, the speed will increase, it will not decrease. Clear? A 3-phase cage induction motor is started by DOL switching at the rated voltage. If the starting current drawn is 6 times the full load current and the full load slip is 4%, the ratio of developed starting torque to the full load torque is. So we have to calculate the starting torque by full load torque. So to that, TST is directly proportional to I2 square into R2 by S. As R2 is constant, considering R2 assumption, the assumption is R2 is constant here. So TST is directly proportional to I2 square by S. So TST by TFL is equal to, I can write IST by IFL whole square into SFL by SST whole SST. So in this way we have derived the formula. We will substitute in this. So the formula is TST by TFL is equal to IST by IFL whole square into SFL by SST. So in the question they have said that the starting current is 6 times the full load current. The starting current is 6 times. So 6 into IFL by IFL whole square into, and the full load slip is 4%, which is 0.04. So IFL square will get cancelled. So you will get TST by TFL is equal to 6 square is 36 into 0.04, and you will get around 1.44. So the starting torque, the ratio of the starting torque and the full load torque will be around 1.44 Newton meter. So thank you everyone.